20, part 3. So part B is actually part of example 10. So here they're asking how many milliliters will the patient receive in 30 minutes. So remember, we were giving 0.5 milligrams per minute. A strength of 200 milliliters had 100 milligrams, and we put our 30 minutes. So then we cross out our minutes, cross out our milligrams, and our answer's in milliliters, which is what we want. 0.5, I crossed out my 2 zeros with my 100. 2 times 0.5 is 1. 1 times 30 gives me 30. So my answer there was 30 mLs. Here, the patient is receiving an infusion of a drug 3 units per minute, IV piggyback. The bag contains 250 units in 100 milliliters of the solution. How many units will they get in 20 minutes? So my answer should be in units. So what's important here is my 3 units per minute, and we're looking at 20 minutes. My minutes cancel out. My answer is in units. 3 times 20 gives me 60. So my answer is 60 units. Notice they gave you a lot of other information that you didn't need. So it was really important just to pick out the information that you needed. So here, how many minutes will it take for 50 mLs of the solution to infuse? So we need 50 mLs to infuse. Let's see, we have 100 mLs, and I'm putting that in the denominator so they cancel, and there's 250 units in that 100 mLs, and we have 3 units 1 minute. So my units cancel, my milliliters cancel. How many minutes? My answer is going to be in minutes, and now it's just a straight multiplication problem. So I take my 50 times my 250, and I'm going to divide that by 300. So my setup's right. 50. Let me do this. Zip, 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 zip. So I have 5 times 25. So when I take 5 times 25, clear that out. 5 times 25 divided by 3 gives me 41.667. So it's about 42 minutes. So why, when I did 50 times 250, divided by 300, there I get it. So I don't know what I did. Alrighty, IV push. We have 500 milligrams of a drug ordered IV push over 2 minutes. The concentration is 100 milligrams per ml. How many mLs will you administer? Alrighty. So we need 500 milligrams. And we have 100 milligrams per milliliter. So we need 5 mLs. So that's pretty straightforward. The hard part comes when we're doing it over 2 minutes. How many mLs will you push each 30-second interval? So think of the 2 minutes in 30-second intervals. So there's 1, 2, 3, 4 30-second intervals in 2 minutes. So I take my 5 milliliters that I'm going to give the patient, and I'm going to divide it by 4 30-second intervals. So I get 1.25 mLs every 30 seconds for the 2-minute intervals. So here we have 750 milligrams is ordered IV push stat over 5 minutes. The concentration is 75 milligrams per ml. How many mLs will we administer? Well, we need 750, and we have 75 milligrams per ml. Milligrams cancel. 75 goes into 75 once. 75 goes into 750 10 times. So I'm going to administer 10 mLs. Now I need it into 5 equal segments. So 10 mLs divided by 5 segments gives me 2 mLs. Since it's over 5 minutes and we're dividing it by 5 segments, that would be 2 milliliters every minute. If we're dividing it into 10 segments, that would be 10 mLs divided by 10 segments, which is 1 ml, and that's going to be every 30 seconds. If we divided it by 5 and it was every minute, we divide that in half again, we're going to get basically every 30 seconds. So in 13 here, we're doing 1500 milligrams IV push sat over 4 minutes. We have 2 grams, and the vial has a strength of 1 gram per 10 mLs. Find how many mLs you'll administer. All right, well, we need 1500 milligrams. The strength is 10 milligrams per 1 gram, and I'm going to change that to milligrams because I have my order in milligrams here. So that's what I need to find out how many mLs. Oh, this should not be milligrams. That should be mLs from 10 mLs here. So we have 1,000 milligrams in 10 mLs. So when I do my math, cancel 1 2, 3, 1, 2, 3. So I have 15 mLs. My milligrams cancel, and I'm left with my mLs. And that's what the question was asking. Determine the number of mLs you will push each 30 seconds, and we're doing it over 4 minutes. So in 4 minutes there are 8 30-second intervals. So I am going to divide 15 mLs by 8 30-second intervals. So I get 1.9 mLs every 30 seconds. Determine the number of seconds needed to deliver each ml of solution. So now I have 15 mLs, 40 in 4 minutes, which is 4 minutes times 60 seconds is 240 seconds. So they want me to figure out how many seconds to deliver 1 ml. So 1 ml, and we don't know X amount of seconds. So I set this up as a ratio. So I have 15 times X equals 24 times 1. Divide both sides by 15. Oops, it should have a 0 on the end. There we go. 240 divided by 15 gives me 16 seconds. So every ml will take 16 seconds. A prescriber has ordered 1,000 milliliters of normal saline with an addition of 200 units of regular insulin IV, infused at a rate of 2.5 mLs per minute. So I'm going to start with my 1,000 milliliters. We're infusing at 2.5 mLs per minute. How many hours will it take? So I'm going to change this to hours right away. So I have my mLs canceling. So 60 minutes is going to go in the denominator so that my minutes will cancel. And I'll put hours in the numerator. I don't have to put this here. My answer would be in minutes, and then I could just convert it. But here it'll do it right for me. So I take 1,000 divided by 2.5, and I get 400. Oh, I forgot to divide it by 60. So I get 6.66 repeating. So that's 6 hours. So I'm going to subtract out my 6 hours. And I'm going to multiply it by 60. And that gives me 40 minutes. So my answer is 6 hours and 40 minutes. Now, if you don't like putting this here, I would have done 1,000 divided by 2.5, and I'd get 400 minutes. And then you just have to say, okay, how many, divide that by 60, and that's 6 hours. So it's the same thing, just how you prefer to do it. So next I will stop it here and do part 4.